Hey, hi everyone. Let's wait until 7 to see if there are more students coming, and then we can start.
Good evening, Dr. Zheng. Can I ask a question before we start?
Okay.
For these live sessions, I try to download it, but I cannot. Could you please let me know how to download it?
You mean the notebook file?
Yeah, like that py that file.
Yeah. I will sh walk through the steps later when we
Okay,
start.
Yeah,
Yeah.
yeah,
that would be great because I'm the same.
yeah, like I cannot download it. I have already practiced what those 11 items in the core app, but I cannot download it. It's funny.
Yeah, that maybe the LMS problems. You cannot just left click it to download it. You better right click the link and select the save file or save link as option and to explicitly choose where you want to download the file. I will show you later.
Okay, thank you.
Sorry, Dr. Zheng. I've got a question about assignment. Is it all right? Can I ask while we are waiting?
I think it's already 7. Maybe we wait until the end of the
Okay,
lab.
thank you.
Okay. Okay, I think it's time to start. Let me share the screen. Okay, let me see. Can you see the share screen at the live session page?
Yes.
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 Okay, great. So you can find all the lab materials here under this lab section, and we only need the .ipynb file. These three notebook files are the notebook we are going to work on. So we will download these files and upload it to the Google Colab and run these files on the Google Colab. And the HTML is just a kind of screenshot of the code result. So you can view it to see some expected result after running the code. But we will mainly work on the IPy notebook files. So to download these files, you better right click and save link as. Can you see that? Save link as, and then you choose where you want to download the file. I will just save it here. And then we go to the Google Colab. You can search the address through the Google, and then you click it. Here, I just change my okay. And then you can select upload and browse the file you downloaded. So this is the one I downloaded. So I open it. And you can see the notebook file is presented. And we have some markdown cells that's just for text presentation. And we have some coding cells. And that is where we are going to write Python code and run our Python code. So we will repeat this process for all the three files. And after you upload these notebook files to the Google Colab, it's actually stored in your Google Drive. So next time you don't need to if you want to access these files again, you don't need to upload it again. So you just go to Open Notebook and go to Google Drive and then find the files you uploaded before. So that should be lab 1 7 should be this file. So this is the new file I just uploaded. And you can just click it and open it again. And all the modification you did last time will be saved, and you can just view it again. So that is how we download the notebook file and upload it to the Google Cloud. So is there any questions? Let's see.
Yes, I'm not able to see this files in my LMS.
So you can't find the files, or what's the question?
Yes,
So
I cannot find the files. Can I share my screen for a minute?
If you go
uh,
into live sessions, it's not
you
in
go
module 1, it's in live sessions in the lab.
yes, you first go to the module 1, that is for week 1 content. Go to module 1 and then scroll down to the live session. The
Oh,
live sessions under module 1, and then click the live sessions and you will find the lab contents.
got it. Thank you.
Hi, just to check, I've been using VS Code for the course so far, instead of Google Colabs, including assessments. That's fine, right?
Yeah, that's fine. But you need to install your own environment, maybe
Yeah.
using Anaconda or using Pig. So yeah, you need to install your local environment.
Yeah, I just
Thank
use the
you.
standard Python 14 point something and the Jupyter extension. It works fine in the VS Code.
Yeah, it should be. I think it only use like sklearn, NumPy, pandas, matplotlib. I think the other dependencies can be managed by the package manager, like Anaconda or something.
A quick thing with when you're trying to run it in VS Code, don't forget to put in a %pip install matplotlib before you run the cell that imports it.
Yeah. Okay, and just for others with no that much coding background, I think Google Colab is the convenient way to start. But if you are comfortable with some local environment like VS Code or PyCharm, whatever IDE, feel free to go with it. And so after we have done some modification on the notebook, we can go to File and Download, and download.ipy notebook. We click that, and then we select where to download the code, and maybe we can rename the downloaded file. And this downloaded notebook file will be the file you want to submit in the for the assignment submission. So you need to submit this IPy notebook file as well as the PDF report. Okay. Okay, if no more questions, we can jump directly into our lab contents. So we have 3 notebook files, but we will look at the Lab 1 script and Lab 1 solutions to the exercise. The Lab 1 exercise file is just it only has the questions in the notebook. So we will look at the solutions to the exercise. It contains both questions and sample answers. So we will go through this Lab 1 script and solutions to exercise in this session. And then I see your questions in the chat. So can the report be a Word document instead of PDF? So it should be PDF. It should be PDF only. You can save the Word document as PDF. Okay, let's continue. So in this Lab 1 script notebook file, we will learn some basic Python usage and its syntax. So after we learn this building block, we are going to use this statement to implement our logic to do some task. And that's the basis for coding in Python. So let's start. So first, let's introduce the basic data types. So like most other languages like Java, C, or MATLAB, so it builds on basic data types like integers, float, boolean, strings, and Python also supports this kind of data, primitive data types. And the first is the numbers. So the numbers are integers and floats work as you would expect from other language. Note that unlike many languages, Python doesn't have unary increment or decrement operators. And the comment start with the hash sign. Here, so to declare a variable, we just simply declare the name. So write down the name for the variable. And to assign value for this variable, we just use equals and providing the number. So after this statement, we declared a variable x that is holding the value 3. So now variable x should be an integer. So if we check the type of variable x using type parenthesis x and print the result. So that should be it will print the type of this variable. So we can see that it is integer type. If we print the variable directly, it will print the value it holds, and we can also use the addition with the plus sign. So x plus 1, so that is equivalent to 3 plus 1. So the result should be 4. And there's also subtraction, multiplication operations available. And here, the double star, that means the exponentiation operations. So this is equivalent to x squared. So, and also equivalent to x multiply x. So the result should be 9. And we also have this plus equals operator, and this is equivalent to x equals x plus 1. So it increased the value of x by 1, and these two statements equivalent. And similarly, we have this x multiply equal to 2, that is equivalent to x equals to x times 2. And the result should be 8. So these two are also equivalent. And we declare another variable, that is y, and now providing a floating number as its value. So now the type of variable y should be a float. So if we check its type, we can see that's float. And we can print the result from multiple statements just in one line and using the comma to separate each statement. And we can see the result are printed all in one line. And the next primitive type will be the Boolean. So for Boolean type, it only has two possible values, so either true or false. And to assign the value to a variable, we're using the similar syntax, but now we don't assign numbers to the variable. We assign either true or false to the variable. And we can also do the logical operation based on these Boolean variables. So we have logical AND, logical OR, NOT operation, and logical XOR. So for logical AND, that means the result of the statement can only be true when both sides of these operators are true, because T and F is true and false. So that means this result will be false. And for all operator, the result can only be false when both sides of the operators are false. So either side of the operator is true, then the resulting statement will be true. So here, because T is true, so the final result will be true. And NOT operator is just if the T is true, then after applying the NOT operator, the final result will be converted to false. So it's just kind of flipping the result. And XOR, that is the exclusive OR operations. And the next primitive type is strings. So the variables can also hold string literals. It can enclose using the single quotation mark, or the double quotation mark. So both format are acceptable and equivalent, but we need to make sure the quotation marks are matching. So if we start with the single quotation, we must end with the single quotation mark. So we cannot mix their usage. We cannot start with double quotation and end with single quotation marks. So that's it. And we can also print the string, and we can get the length of the string. The length of the string is the number of character stored in this string. So for this hello string, we have 1, 2, 3, 4, 5 characters in this string. So the length of this hello should be 5. And we can concatenate the string. And so here, using the addition operator, so hello plus space plus word, the resulting string would be the hello world with a space in between. And we can also construct a string using this sprintf style string formatting. So here we first specify the format of the string. We use this %s, %d as the placeholder. So it is formally called a format specifier, but you can treat it as placeholder for some undetermined value. And the actual value for these placeholders are specified in this parentheses. So the value for the first %s should be same as should be inserted by the value of this first variable, so hello, and the word should corresponding to the second %s, and the third 12 integer is corresponding to the third placeholder, that is %d. So after specifying this format, if we print it, we can get hello world 12. So this is just using the values specified in this parentheses to replace the values specified in this format string. Okay, is it all right till now? Okay,
So,
okay.
Doctor, that S and D, is that S for string? Is that
I
percentage
mean %d or
percentage mark and S?
%s means string. It is a
Okay.
kind of string placeholder, and %d is for integer.
Okay.
And there's also like %f that is representing for the floating number. And you can also specify the precision of this floating number. Let's see, 0.2. We write another number. Let's try to run it. You can see that there's another floating number printed, and this is the precision .2. That means we need to keep 2 digits after the dot. Okay.
Mm-hmm.
And the next concept is containers. So Python includes several built-in containers type: list, dictionaries, sets, and tuples. The first container is list. So list is the Python equivalent of an array. So it is resizable and it can contain elements of different types. So the index of this list start from 0. And for example, if there is a list that is holding 3 elements, the first element 3 will be index 0. So if we access the elements at index 0, we will get number 3. So this Python list is 0 indexed. Okay, we can print the entire. This is how we declare and construct a list in Python. So we give a variable name equals and the list with their elements. So we use a square bracket to enclose all the elements should be in the list, and we need to specify the elements values in order. And to print the whole list values, we simply give the variable names. And to get specific elements value, we need to use the square bracket and providing the index of the elements. So access square bracket 2, that means we are going to access the third elements. So that will be the number 2. And it also supports negative index. So -1 means it will count from the end to the start. So -1 means the last element. So it will also print 2 again. If we change it to -2, that will be the second to the last element. So that will be pointing to the number 1. And we can change the element's value by assign specific values to the to certain index location, right? We can replace the index 2 elements with this string foo. So after this statement, the last element is not 2 anymore. It will be replaced by the full string, right? Now the last element is this string. And we can add new elements to the end of the list by using the append function. So the list name dot append function and providing the elements we want to add to the end of the list. So here we want to add this bar string to the end of the list. We can see that after running the statement, we have bar string that is at the end. And we can also use the pop method. This pop method will remove the last element and then return this last element as the result. So after executing this line, the removed element is the bar string, and this bar string will be assigned to variable x, and this bar string will also be removed from this XS string. So if we print the result, we can see that the value of x is this bar string, and the value for this list now doesn't have the bar string as the last element. And now we have learned how to access a specific one element in the list. What if we want to access multiple elements or continuous elements in the string? We're going to use slicing. So in addition to accessing list elements one at a time, so Python provides concise syntax to access sublist. That is called slicing. So here we just create a list of 5 elements. So the range is just creating a range of integer value from 0 to 4, because that is right exclusive. So it will not include 5. So it will create a string. It will create a list of 5 values from 0 to 4. And what if we want to access the element index from 2 to 4, but 4 exclusive? We are going to use the square bracket and providing the index range. And the index range is from 2 to 4, 4 exclusive. So this range start and range end separated using the colon. Please note that this slicing is right exclusive. So the index 4 elements will not be returned. So for this statement, the returned element are index 2 and index 3. So we can see that there are only 2 elements returned, and the result is also printed here. We can omit the end index. So that means we're going to return the sublist from index 2. So we can see that the result is 2, 3, 4. That is starting from the index 2 until the end of the list. We can also omit the start index. And that means the sublist will start from the beginning to the specified end index. And this end index is exclusive. So here the result will be only the first two elements. And if we ignore both the start and end index, that means it will return the whole list. We can also use the negative index. So this means we will start from the beginning, and it will stop at the last element of the list. And the last element is exclusive. So it will return the whole list except for the last element. And we can also update the sublist. So we just specify the index range and provide in the updated values or updated list. And we can get the length of the list. So by just using the len method, providing the list variable as the parameter. So the len function will return the number of elements contained in this list. And we can also sum all the elements value up by using the sum function and providing the list variable as the parameter. And here you can see the printed result. Is that all right for the list? And next we will see how to use loops over to loop over the elements of a list. So assume that we have a list of animals, and here we create a list with 3 elements. So cat, dog, and monkey. And now we want to print this element's value each on a single line. So what we can do is we can use for loop to loop through each element inside this list. And for each element, we just use print, providing the element's value to do this task. So here we use for loop. So for followed by like tracing variables, and then keyword in, and then followed by the list variable. Remember that the for loop, the first line of for loop should finish with the colon. And inside the for loop, we're going to specify the task for inside each iteration or each loop. So here we simply want to print the value of the elements. So here we just use print. So for each loop, the value of the animal will be changed to each element's value. And after this for loop, so all the elements value will be accessed once. So with this syntax, we can only store the elements values in these animal variables. What if we also want to know the index of these elements? We can use the enumerate functions. So here we don't provide the list variable's name directly. We use the enumerate function to encapsulate the list variable. And then we use 2 variables to loop through this result of enumeration. That is the index of the element and the animal variable. That will be the variable holding the element's value. So inside each loop, we just simply print the index value and the corresponding element value, and the result will be like this. So in this way, we can have both index and element value information available inside each loop. And list comprehension, that is I think it is unique in Python, and it is more a Pythonic way for coding. So when programming, frequently we want to transform one type of data into another. As a simple example, so consider the following code that compute square numbers. So suppose we have a list of integer values start from 0 to 4. And now we want to get another list that is holding the squared value for this element. So the conventional way of doing this is we loop through all these elements in the nums list and then calculate the squared value of this element and then append it to the another new list, new empty list. Then at the end of the for loop, the squares list will store all the squared values of the nums element. But we can also do the same thing using the list comprehension. So we have the same nums list, and here to get the squares list values, we state it in this way, and this is the list comprehension. So it is encapsulated in this square bracket, suggesting that the result is list, and inside this bracket, it is stated that the element should be the squares of variable x. And what is the value of x? That is each element in the nums list. So the resulting result would be it will looping through each element in the nums and then squares the value stored as the elements in this squares list. So the result will be the square numbers stored in the squares list. We can also provide some condition, specify some additional constraint or conditions to the list comprehension. So we can specify we only need squared value if the remainder of x divided by 2 is 0. So only when this condition is met, only when this statement is true, it is going to calculate the squares of x. So now we can see that we don't have the 1 and 9 values anymore. So we only have 0, 4, and 16. That is corresponding to 0, 2, and 4, because only these three elements have remainder that is divided by 2 is 0. Okay, and that is for the list container. And for dictionary, the dictionary is used to store key value pairs. So it is unlike list. List is only is used to store single value elements, a list of single value elements. But dictionary is used to store key value pairs. You can have like multiple key value pairs stored in one dictionary, but each element is a key value pair. So when we construct this a dictionary, we need to specify the key its key value pairs. So the key the declaration of this dictionary should start with the curly braces. So that suggests that everything in this curly braces will form a dictionary, not other type of container. And to specify each element in this dictionary, it should start with the key value. Here the key value is cat, followed by a colon, and then followed by the value. So that is cube. So this cat colon cute forms one key value pair. And we can specify the second key value pair, that is dog and furry. To get an entry from a dictionary, we need to access the value through its corresponding key. So if we want to access this cute value, we need to access it through the key cat. So we provide this key value to the dictionary. And now we need to use the square bracket to access a specific element and providing the cat as the key to access. And we can also check if certain key exists in the dictionary using the in keyword. And the return type should be a Boolean value. It should be either true or false. So if it is true, that means there's such key in the dictionary. If it's false, that means the dictionary doesn't have such key. So this statement will return true, and this should return false. This should be a typo. And we can also assign new key values after we have created the dictionary. So we can specify a new key, that is fish, and then assign the corresponding associated value as white string. So now the dictionary should have another key value pair, that is fish colon white. And if we access the value, we can access its value through the key. We can what if we are accessing a key that is not stored in the dictionary? For example, this monkey. It will raise an error. So a safer way to do that is we're going to call the get function. The get function will first check if the provided key is existing or not. So if the key doesn't exist, so it will return the default value specified as the second parameter. So because monkey is not a key in this dictionary D, so it will return this NA as the return value. So this time, the statement will not raise an error. So it will return a default value. So it will not terminate your program. So it is a much safer way to access values through the key. And we can also delete certain key value pairs through the key. So we use the DEL, the delete keywords, and providing the keyword, the key of the key value pairs. So D squares and the key we want to remove. And this time, if we want to access the key value pairs again, we can see that the return value is NA. That means this key value pairs is no longer stored in this dictionary. And to loop through the dictionary, we can still use the for loop. So given this given this dictionary with 3 key value pairs, we're going to use the for loop to loop through each pairs in these loops. So in this pair, in each loop, the animal will be the key for each key value pairs. So to get the value of these pairs, we need to access this value through the dictionary and this key. So we need to provide animal as the key to this dictionary, and the return result will be the value for the key value pairs. And we can print the values using the print statement. Just note that when we use for loop to loop through the dictionary, the animal variable here is storing the key, not the key value pairs, not the value. It is only the key for each pair. So if we want to access keys and their corresponding values, we can use the items. So now we will have two variables to keep track of the keys and their corresponding values. So animal variable is still storing the key, and now we don't need the D square bracket animal to access the the value. We can have the lex variable to store the actual value. If we are looping through D dot items instead of the dictionary directly. And we also have diction comprehension as well. So these are similar to list comprehensions, but allow you to easily construct dictionaries, for example. Here we have a list of numbers, and we want to construct dictionary based on the information for this list. Here we specify the for loop for this list comprehension. So for each element in the nums list, we need to check if the value of x has a zero remainder after divided by 2. So that means only 0, 2, 0, 2, and 4 meets the requirement. So if the value of x meets the requirement, then we are going to construct a key value pairs. The key should be the value of x, and the value for this pair should be the square of x. So after this dictionary comprehension, so the result will be 0, column 0, 2, column 4, 4, column 16. So that is the original value as the key, and the squared value as the corresponding value for the pairs. And the next container would be the set. So a set is an unordered collection of distinct elements. Let's look at the following example. So we construct the set that is similar to the dictionary. We are still using the curly braces, but now for each element, we are not specifying the key value pairs. We only specifying the element or the value for the elements. And the set support checking if an element exists in the set by using the keyword in. So cat in animals is going to check if this element is already stored in the set animals, because it is inside the animals, so the result should be true. And then if we are checking if fish is in the animals set, it is not, so the return value would be false. We can add new elements to the set by calling the add function. And then if we check it again, it will return true. Before we add it, it is false. So that means this element has been added to the set successfully. And we can also check the number of elements that stored in the set. And now it prints 3. So we have cat, dog, and fish. So we have 3 elements in this set. If we add elements that is already stored in the set, it will show no errors, but the program doesn't do any changes. So there's nothing changed in the set. So if we print the element of the set, we still get 3. We can remove specific elements using the remove function. And then after removing the element set, element cat, we have animal set that has only two elements. So we can loop through the set using for loops. So iterating over a set has the same syntax as iterating over a list. However, since sets are unordered, you cannot make assumption about the order in which you visit the element of set. So that means you cannot expect the cat element will always be accessed as the first element, and dog is the second, and fish is the third. You cannot assume this order because the set stores these elements in an unordered fashion. So if we loop through the elements in this set, we can see that the first element that is accessed is fish, not the cat. And the second is cat, and the third is dog. So that means this element are stored unordered in the set. We also do the set comprehension, just like list and dictionary. And the difference is we are using curly braces, and we don't specify key value pairs just as the dictionary comprehensions. Here for set comprehensions, we just specify the element value. And the last container will be tuples. So a tuple is an immutable ordered list of values. So a tuple is in many ways similar to a list. One of the most important difference is that tuples can be used as keys in dictionaries and as elements of set, while a list cannot. Here's an example. So we construct tuple using the parentheses. So recall that we are constructing a list using square bracket, right? So a tuple is like an immutable ordered list. So we are using parentheses to construct the tuple. And we can create a dictionary and using tuple as the keys. So here is using the dictionary comprehension to create the dictionary. And we can see that we can use the tuple as the key for the key value pairs stored in the dictionary, but we cannot use the list as a key. And if we check the type of this tuple, we can see that the type is tuple. And we can get specific elements in this tuple by providing the we can get the specific value from the dictionary by providing the tuple as the key. So it will print 5. And we can also explicitly create a tuple and then provide it as the key values to the dictionary. And it will print the corresponding pairs value. And here, the last statement is just printing the entire dictionaries. We can see that for each element in this dictionary, we got the tuple as the key. Is that all right for the containers part? Okay, let's continue to the function. The Python function are defined using the def keyword. So it start with the def. That means the following will be defining a function, Python function. And then it's followed by the function name and the parameters list. and then end it with the colon. And then inside the function body, we define the logic for the functions. Here, in this function definition, so it defines a function called sine and providing it accepting one parameter, x. And inside the function, it is going to check if x is greater than 0. If this is true, then it returns positive string. If it is smaller than 0, then it is going to return negative string. If the conditions for if it is other conditions, then it will return 0. So this other conditions will only leave x equals 0 to us. And then we can call, with this function defined, we can then later call this function by just referring to the function name and providing a certain variable as the parameter. So here, we're using for loop to loop through the list with 3 elements, 0, -1, 0, and 1. And then for each element, it is going to check the sign for each element and print the corresponding string. So we can also define functions to take optional keywords arguments. So here, for the definition for the function, to define optional keyword arguments, we can use the equals and providing some default values. So in this way, we can call this function by providing only the name parameter without the second parameter. And then the second parameter will just use the default value defined in the function. Of course, we can provide 2 parameters values for all the parameters. We can also specify the load parameter should accept true instead of using the default false value. And to define Python classes, we simply use the class keyword and providing the class name, and this is the inheritance of the objects. We can just and the definition should end with the colon, and the class definition should contain the constructor and the instance method. The constructor should follow this format, so it must have this name like double underscore init and double underscore, and then providing the first parameter as self, that's the keyword, and then that's the name that is going to hold the variable for the instance variable. And to access the value for instance variable, we need to access it through the self variable. So self.name, that means this name will be the instance variable, and this name is the value you passed into the constructor. To define an instance method, you can choose any name for the instance method, but the first parameter for the instance method must be the self. And so after we define this instance method, to call this instance method, it must be called through the object or instance of this class. So here we can see that we first create an instance of greater class by providing the name. So with this statement, it will call this constructor and matching this string to the name variable. So in this case, after we create this instance, the instance will hold its instance variable name with value flat. And then we can only call this instance method through the instance. So we cannot call the function greet directly. We need to call it through g.greet. G is a constructed instance of greeter class. So g.greet to access or to call this instance method. And we can also provide, because this load is an optional argument, so if we ignore it or omit it when we call the method, the default value will be false. And we can explicitly specify the value for this load argument. Okay, let's pause here and have 5 minutes break, and then we will continue at 8:07 to finish the rest of the content. Okay? Okay, let's continue. The next section will be about how to do the plotting using the matplotlib. So it is a library specific use for plotting some diagrams with your data. So first, we need to import it. So we need to import matplotlib.pyplot as PLT. So that is convention name for this import. You can also rename it to whatever, like plotty or like plotty or whatever name you want, but you need to import it. And then we specify matplotlib space inline, so that will make sure the plot will be displayed inline for notebook. So that is for the notebook usage instead of pop up this generated diagram. And to plot for the basic plotting, we can just use PLT. That is the name you imported, the plt.plot, and providing the list of values you want to plot. And we can set the label for the y-axis, providing the string as the name for this y-axis label. And we use plt.show to show the diagram. So we can see that with this command, we can plot a straight line here in this diagram. And the sum numbers, that is the y-axis label we specified here in this statement. And these four values are the corresponding y values for the point on this line. Because we didn't plot the point explicitly, we cannot see the point clearly in this line, but this is actually connecting the four data points using the straight line. The four data points should be 0, 1. The four data point should be 0, 1, and should be this one. 1, 2, and 2, 3, and this one. 3, 4. Okay. Here, because we only provide the one list of values, and this list of values should be treated as the y values for these data points, and the x values will be using a list of integers start from zeros, and the number of x data should be same as the length of the y values we provided. So that's why we have 0 as x, 0, 1 as the first data point, and 1, 2, that is the second data point. 2, 3, that is the third one, and 3, 4, that should be the fourth data point. And connecting these four data points would form this straight line. And we can also explicitly specify all the data points positions. So here we can provide a list of x data and a list of y data. And we can provide both lists to the plot function, telling the matplotlib that the data points x coordinate are stored in the first list, x list, and the y coordinates are stored in the second list. the Y list. And we specify the label for X and Y axis, and we show it. And we can see that this kind of turning point corresponding to the data point we provided. So we can have 1, 1, that is the first data point, and 2, 4, that is second data point, 3, 9, that is the third data point, and 4, 16, that is the fourth data point. So now we can draw this kind of curved line using the plot function and providing both X and Y data values explicitly. And we can also change the style of the plotting. So we can change the color of the line. We can make the data points more explicit. And we can specify the style of the line. So here, we specify the style by using this kind of format string. So here, R means red. So the line would be colored using the red color. And this O it means circle. So it is going to use circle to represent each data point. And this dash, that means straight line. So there are other options available to use. You may want to check the documentations for this plot function to see other options. But we can change the style for this plotting through specify a format string in the plot function. And also we can set the length of the axis. We can set the range for that. The first two values corresponding to the length of the range of x-axis. So it should start from 0 to 6. And the third and fourth values are corresponding to the range of y-axis. That should start from 0 to 20. And we can also draw very smooth curved lines using the plot function. So here we use NumPy library for assistance. So the NumPy library here is just used to create some matrix or vector. So it is used to create a one-dimensional array. So here is that NP, that is the abbreviation for this NumPy. So np.arange, it will create an array with specified range. So it will start from 0 to 3 times pi value. And then the interval should be 0.1. So that means for every 0.1 difference, it will draw a data point. And it will then calculate the corresponding y value for each x value in this array. So it is going to calculate the sign for each x value by calling the np.sign function. And then it will explicitly create a figure to draw, and then plot the x and y value. And these are two array of data points coordinates. And then it call the plot plt.show to show the diagram. And now we can see a much smoother curved line instead of this kind of line with clear angle. And here we can also plot multiple curves in the same diagram. So here we're using the same set of x coordinate, that is using the NumPy array. And then we calculate the first set of y coordinates using the sign function. And the second set of data points y coordinates are using the cosine function of the x coordinate. and then we can plot the first series, that is using the x coordinate and the sine result of the x coordinate. And the second series would be the x coordinate along with the cosine values as the y coordinate. And then we specify the label for x and y coordinate and specify the title for this diagram. And we also set the legend text for each series. So the first series is corresponding to this first plot function, and the second legend name is corresponding to the second plot functions. So in this way, we can see that we can plot both curves in the same diagram, and we have legend here to demonstrate which curve is corresponding to which series. And we can also draw the histograms using the matplotlib library. So here we also use the NumPy array, the NumPy library to help generate some random data. So here we just set a random state for the seed for the random machine, and then we use the np.random.randoN method. So this will generate a data with 500 rows and 1 columns, and values in this data structure or in this data randomly generated with value between with mean value, mean 0 and variance 1. And here we specify the number of bins, and these bins will be used to specify the number of bins in the histogram. So with this data generated and bins value specified, we can call the hist function, providing the data and the number of bins. And we call the plot show to show this histogram. Okay, that would be the basic usage for the Python. So you don't actually need to memorize like how to call this like plotting method. So when you need it, you can just check some documentations to find what type of plotting you need and what kind of syntax you can use to plot the diagram you want. But for this basic syntax, like the primitive data types and list, those kind of containers, functions, classes, you'd better understand what the syntax means, so that when you read the code, you know what the code is doing. Okay, is it all right for this lab 1 script? If no questions, we will go to look at the exercise.
Sorry, it's Kathy here. With the last graph, you had where do you get the info? I know it says it's random, but if I press the run, it's the same shape. Is that how does it where does the information distribution of the graph come from?
Because we
That's
have
right.
already set the random seed as 1,
Okay.
You have
that's
to,
for reproducibility. So if we change it to maybe 2, and we will get another new shape.
Okay.
So it's kind of
So it's not
Random,
random. It's already preset. Preset. You've
not
got
kind
one.
of preset. It means it is kind of
It
random.
means that you can get a random value, but it has repeatability in it. If you set the same seed, you get repeatability, but you can change the seed to get a different sequence of random numbers.
Okay.
Yes.
Okay. Because I thought, well, if I didn't know because I pressed run again, thinking it's random and it would be a different graph. But okay, yep, good.
Yeah.
Thank you.
The
The
beauty
values
of having
are
the same seed, Kathy, is that you can reproduce stuff based on that one seed.
Yeah.
If you want a different random number sequence, you just change the seed.
All right. Yeah. Thank you.
And also, didn't quite understand what is numbins, like how is it coming up, like how are we plotting it there in on the line plt.hist x comma numbins.
okay. So do you know what histogram mean?
Mm.
So the x-axis is kind of value range, right?
Yeah.
The y-axis means the count
Mm-hmm.
of numbers falling into this value range, right?
Yep.
So the number of bins means how many bins or how many such kind of bars we are going to use to represent the whole value range, the whole x value range. So if we said maybe we just use 3 bins, we only have 3 bars
Okay. Okay.
to represent the whole data distribution.
Sure.
If you look earlier, we had 500 values. So we're putting them into that number of buckets or bins.
Mm.
Yes, so that means how like for this one maybe 10 values fall into the range between like 2 to 4. It's just like that meaning.
Yeah. Got it. Understood. Thanks.
Yeah. All good?
Where the 500 values going? Is the
X
500
equals np.random. Look at the two parameters.
Here. So this function will generate 500 random values.
is this X going to the X legend,
Um,
which is a horizontal line, these 500 numbers?
500. The y-axis, that is the count falling into each bar or each bucket, and then the total number of these numbers will be equal to 500, and the value range is determined by the range of this randomly generated 500 values.
Okay.
Okay.
Yeah. Kind of, yeah.
Okay. Let's go to the exercise notebook. For question 1, assume a kid, Bob, is 10 years old. So to create this profile information for Bob, now assign a value of Bob to the variable name and assign a value of 10 to the variable age and print the variable type for both name and age. So we have seen that we have learned the way to declare like string variables and integer variables. So name should be a string variable. So and we just assign the string value Bob to the variable and assign the value 10 representing the age of the kid to the age variable. And then we will print the type of name and age variables by using the type function. The type function will return the type of the provided variable. And for question 2, print the name and age with as printf style string formatting. The print result should be Bob is 10 years old. So for the expected output, Bob and 10 should be the value contained in the variable. So we use two placeholder to represent these two values. And the rest we just use plain language to in the string. And then because Bob is a string value, so we use %s, and the 10 years old, the 10 value, that is the integer. So we use the %d as the placeholder. And then we specify the value for these two placeholders using these parentheses. So name corresponding to the first %s and age corresponding to the second %d. So in this way, we got the string formatting specified. And if we print it, it will show the expected string as the output. And for question 3, create 3 dictionaries for 3 students in a class. The dictionary for each student have 4 keys. So name, homework, quizzes, and tests. Since there are more than one homework, quiz, and test, you will need to use list to record them. The first student is Cassie, and the information is like this. And the second student is Alice, and the third student is Tyler. So now create 3 dictionaries for 3 students. So to create dictionaries, we have learned that we need to start with the curly braces, and the dictionaries storing the key value pairs, right? So we need 4 keys. So the first key should be the name, and second key should be the homework, and third is the quizzes, and the last one should be test. And for the name, the pair with name key, we should store the value for this person, the name value for this person. And for the homework, it is associated with the scores for her homework. So it should be a list of floating points values, right? Because there are more than like one scores for homework, quiz, and test. So for homework, quizzes, and test, so all the associated values should be a list of floating numbers, right?
Can I make a comment here? These
Yeah.
examples in this lab are terrific for the first time since the introduction to programming course. Python dictionaries and lists make sense to me. Wonderful, thank you.
Okay.
Can I ask one question? Can those value are different type? For example, with the homework, the value type of the homework is list. Can Casey has the list and homework, and Alice just one of the number in homework?
So I didn't get the question. Sorry. You mean the homework is a list of floating numbers?
Yeah.
Yeah.
So in these 3 dictionaries, all the homework, the value of the homework are lists.
Yes.
But are they allowed to have different type? Like Cassie's homework is list, and then Alice's homework is only one number or integer.
It can
or
be,
float.
but it depends. From the syntax point of view, it is allowed, but from the logic, maybe it's not that useful. Maybe you can have a list of one element so that we can have like same type of data types stored in these dictionaries, so that later on when you access the values, you won't need to double check if the associated value is a single integer or single float value, or if it is a list of values. So you can always expect that the returned value from homework keyword will be a list of values, although the list can have only one element. Does it make sense?
Yep. Yep. Cool. Thank you.
Okay. For question 4, create a gradebook for the 3 students using a list. So just straightforward. So we already got the 3 dictionaries defined. So to put them into a single list, we just use a square bracket to enclose all the 3 dictionaries variables. Okay. And question 5, for each student in your students list, print out that student's data as follows. So print the student's name, print the student's homework, print the student's quiz, print the student's test. So here, we want to loop through the students list. Since the student list is it's a list of dictionary, but no matter what type of elements is stored, it is a list. So we can use the for loop to loop through the list. And now the student variable should holding each dictionary element, right? So to access the name keyword or the name pair, we are going to use the student, that is the dictionary name, providing the keyword, and the return value will be the associated value for the name pair. And similarly, to access the associated value for homework, so we can just provide the keyword homework to this dictionary student, and so on. So we use the similar syntax to access the associated value for quizzes and tests. So that would be the printed result. And plot the 4 homework marks for Cassie using red line and circle marker. You can create the x-axis as the order of the homework. Okay, so we first define a list of 4 values. So that is representing the order of homework. And then it should be provided as the x-axis value for all the data point we are going to plot. And for the y-axis, we are going to provide the homework score list as the y-axis. So with this statement, Cassie homework, so it is going to return this list of values, right? So this will be provided as the y coordinates of the data points. So let's say x should equals to y should equals to this, and we should be able to print 4 data point with this coordinate specified, right? So the first data should be 190, second one is 297, third one is 375, and the last one is 492. And then we specify the y label and show the diagram. So we can see that we are using the red straight line to connect all the 4 data points representing the homework score. And then we specify we want to see the circle representing each data point. And here is the plotted result. And for question 7, to write a function average that takes a list of numbers and returns the average. So define a function called average that has one argument numbers. Inside the function, call the built-in sum function with the numbers list as a parameter, store the result in a variable called total, use float to convert total and store the result in total. Divide total by the length of the numbers list. Use the built-in length function to calculate that, return the result. So first, it asks us to write a function average that takes a list of numbers and returns the average. So we know that to define a function, it starts from the keywords def, and then the function name should be average, and it takes a list of numbers. This list of numbers will form a list, and this list will contain in a single variable. So we just use this numbers variable to represent this list of numbers. And to calculate the average, we need two numbers, right? So we need the sum of the numbers, and we need the number of elements in this numbers list. So we need these two information to calculate the average of the numbers. So here, the total, to get the total of these numbers, we can use the sum function because this numbers is a list of numbers. So we can call the sum directly on these numbers to get the sum of all these element values in the list. And we can get the number of elements in this list through calling the length function, right? So this will give us the number of elements. And we use total divided by the number of elements. That will be the average of the numbers in this list. And finally, we return this average as the return value for this function by specifying the return keywords. And here is an example of calling this defined function average. So for question 8, so write a function called getAverage that takes a student dictionary as input and return his weighted average. Define a function called getAverage that takes one argument called student. Make a variable homework that stores the average. This is a function that you just created of student homework. Repeat the last step for quizzes and tests. Multiply the 3 averages by their weight and return the sum of homework. This is the weight for the 3 assessment. Right? Homework is 10%, quiz 30%, and test 60%. So we have already got the average function defined, right? So to get the average score for the homework, we only need to provide the homework score list as the parameter for this average function. And the return result will be the average score for the homework. And we repeat it for quizzes and tests because all the quizzes and test scores are already stored in as the list, and it can be accessed through the keyword quizzes and test in the dictionary. So with average score calculated for homework, quiz, and test, we can calculate the weighted sum for these 3. So the final score would be the individual score multiply its weight and sum these 3 terms together, and that would be the final score. So that is just according to the formula provided in the question. And then we can, since this getAverage function only accept one dictionary as the parameter, we can simply call getAverage and providing each student dictionary as the input. And then the returned result will be the final score for a specific student. So that would be 80.55.
I have a question about question 9, please.
Yes.
I noticed that the invoked function in question 8 returns floats, but you are in your if and elif tree, you've got integers. How does Python handle the integer float conversion for the comparisons?
For comparisons, it can directly compare the float
I mean,
and
does it end up comparing a float with a float, or does it the 90 become a 90.0 because a float is being compared, or for score?
for
Score is returned from the
calculation
score is a float.
yeah
Is a float,
yeah
but you're comparing it against an integer.
It doesn't matter. It won't change the like variable types when you do the comparison. But for calculations, like if it is calculating like score maybe +1, maybe let's say X.
That's fine.
And
So
then
it's important for arithmetic calculations, but not for comparisons.
yes,
Yeah.
yes, not
Thank
for
you.
comparison. So for calculation, it will convert the result to float.
Sorry. I'm just trying to translate the Python to the old legacy languages that I used. Thank you.
Okay, yeah, that makes sense. But you don't normally you don't need to worry that much about the types because Python is not that strict typing. So you know you can recall that we don't specify what type of variable it is when we do the declaration of
So
variables.
it's just a habit from a background in programming. That's all.
Yeah,
Sorry.
yes, and that makes sense. That totally makes sense. Yeah. Okay. For where were we? Okay. For question 9, so define a new function called getLetterGrade that has one argument called score. Expect score to be a number. Inset your function test score using a chain of if, else if, else statement. So these are the conditions we will need to translate. And finally, validate your function. Call the function with the result of getAverage void. Print the result in letter grade. Okay, to define this function and translate this plain language into the code. So as requested, we need to define the function. Function is called getLetterGrade and is received as it said, it has one argument called score. So we need to specify it is accepting one variable as the parameter. And then we are going to check if score is greater than 90. So if so, we need to return A. So we then return A. If this condition doesn't match, it will go to the next condition to check if the score is greater than or equals to 80. And then if so, it will return B and so on. It will do the rest. And don't change the order for these conditions because it will break the logic, right? So if we first check the score, let's say we first check if it is greater than 80%, 80. And then if it is greater than 80, we set it B. That is totally violating the logic, right? Because that is the first for if and else if statement. It will be executed in this order specified. So it will first check if the score is greater than 80. So if the condition is met, it is going inside this if clause and return B. What if the given score is 90? It should be given A, but because it also meets the first condition, it will go to B. So it totally violating the logic. So when you are writing this kind of if and else if clause, you better be careful with the order of these conditions. And then we can validate the result by calling get average Cassie that will calculate the final average, the final score, the final weighted sum score. And then we call the get letter grade by providing the return value of get average that will return the corresponding grade for the final score. And for question 10, to define a function called getClassAverage that has one argument, gradebook, you can expect gradebook to be a list containing your students, 3 students. First, make an empty list called result for each student item in the class list, calculate get average, and then call append with that. Finally, return the result of calling average with result. So here, again, as requested, we need to define a function with required name, so get class average, and it accepts one argument, that is gradebook. And inside this function, we will use an empty list called result that will keep recording each student's final weighted score. And then after we got the list of weighted score, we can calculate the average for this for all the students. So first we need to fill up this list of final scores. So we loop through each student in the gradebook. We calculate the average score for each student, and we append this specific student's final score to the results. And after looping through all the students in this gradebook, we will get the results list filled up with all 3 students' final average score. And then we calculate the average of this list. And that is the average score for this class. Okay, and the last question, no, use get letter grade and print the class average. So we have already got the get letter grade function defined. So we simply just provide the class average score to the get letter grade function, and we will get the corresponding grade for the class average. Okay, that would be all for the lab contents. So, any questions till now?
Got one. Is this something like this lab 1 exercise? Is this something we will get in the exam? Because this looks like basic coding.
The final exam won't test your coding skills. You will not be asked to write code in the final exam. So the final exam will be about testing your understanding about the concept and their usage, pros and cons, and like understanding of the modeling and their applications and so on, and some underlying theories, those kind of stuff. It will not ask you to implement using code.
Okay, so these lab solutions are created just for our understanding of each week.
It will help you to prepare the assignment because you need to do coding for
Yeah.
assignment.
Okay. All right. Cool. Thank you.
Or
So yesterday we spoke, and not yesterday, sorry, Wednesday. You were saying that after tonight's lab, we should be able to do task one of the assignment, of assignment one, sorry. I'm still looking at it, and I'm like, okay, so I'm not sure what there would help me load the data set. Well, that's a
you get
CSV file. You know, that's file handling there. Is there file handling required?
you should find you better see the contents in. I think the regression notebook in week 2 will help a lot. Let
Oh, I
me,
just saw that. Yeah, there was an attachment for CSV file. So maybe in there they show you how to load the
yeah,
CSV. Okay.
it will tell you how to load and clean the data and do some analysis and so on. So you better preview that, and yeah, that would be helpful.
Okay, so I have to jump ahead to lab 2 to begin the assignment this weekend. Okay. Yeah.
Yes, because some students don't have the coding background and also don't have the Python coding background. So for the first week, we need to prepare some fundamental like syntax knowledge for them to start.
Okay. I think, yeah, I'll have to start the assignment this week because it's due next week anyway. So, yeah, thank you.
Yeah. Okay, all good. Then that will be all for the lab session. And we still have like 1 hour student consultation time. So if you have other questions, just
I have a final question. I have just final question. And this assignment one, now do the regression. Can we use I'm using the library functions in the Python to do the regression. I don't write the regression function. There are
what
functions.
so what function are you talking about?
Regression, linear regression and SVM. There are functions in the library, Python library to the linear regression. There's function called linear regression, and I
Yeah,
just
yeah.
call the function
I mean,
in the
if you
database.
preview the lab notebook in week 2, it will talk about how to use the linear regression model and SVM models in the lab notebook. So you can borrow the code there, and you can see how to use them. We will use the scikit-learn library for those for those models. You don't need to implement your own models.
Yeah, what I mean is you can just call the function. No, you don't have to write. Well, where is this note, lab notes, please? Can you give me the link to where do I find the lab notes?
A lab note for what?
For this assignment for the linear regression.
I haven't talked about that.
I know you're not talking about that. I know that the assignment you have to do the linear regression.
So you just check the week 2 lab notebook is here, like in module 2 lab sessions.
Module 2 lab session. All right, okay.
Yeah, to just look at the lab 2, module 2 labs, there's no regression answer. It has a classification answer. Notebook.
I think the answer is already in the notebook, so it didn't specify because the class we will not have enough time to go through both regression and classification, but like 90% of the code is the same, so we will fully go through the regression and put the classification as your like homework or home practice. So we provide the answer for classification, but the regression you should have already the notebook should already have the answers in the notebook. Yes, it already have the answers, right? If you check the regression notebook. you have this. Can you see? Am I still sharing the screen?
Yeah, you are.
Yes,
Okay.
you
Yeah,
can see there are code there, and together with the generated result, and yeah, it has answer together with it. But for
okay, cool.
classification, it is split into like two notebooks, like one with question only and one with question and answers.
Yep, I haven't checked this, so yeah, cool. Thank you so much.
Will you be needing like a description of the code for each code line, or is it okay if we describe what we are doing in the code at the top and then the code at the bottom?
I would recommend you just like the notebook here shown in the lab 2, you split your code into cells and put a short description like what this is doing, like what kind of result you are expecting. Like let's say here you are expecting it is dropping some columns or dropping some rows. So and the result is shown in the next coding cell, like something like that. Yeah. So just organize it as what the lab notebook looks like. But you are not expecting to write that much like teaching kind of contents, but you need to add some short description alongside your code.
Okay. And did you get answer about the amount of AI that we can use, AI planning, AI collaboration?
Yeah, it just confirmed that the category is no AI. I just made the announcement.
Oh, okay, thank you.
Well, you mean no AI at all?
Yes, no AI
I
at all.
often ask AI to help me solve syntax problems or to explain concepts.
The important thing is you understand the knowledge. Like, I mean, you better not rely on the AI to generate the entire like the
Oh, no,
result and copy and paste
no.
the answer. But
So I shouldn't be using
if
continue.dev
you are
in my VS Code.
Yeah, if you are using it like help you to understand the concept or like a search engine,
Yes.
that is fine.
Okay. Thank you.
Yeah,
Dr.
but you better not just generate the answer directly, because we should have
Oh, no,
experience
that's a
that if
waste
we
of time.
just
Yeah.
use the AI or AI agent to generate the code or
Yeah,
something,
like
yeah,
a
we
tame
totally
tutor.
lost what it is doing. But yeah, sometimes we're
I
lost.
use it as a tame tutor.
Yeah.
Doctor, please tell me where do I find the lab 2 session, lab 2?
You go to the module 2. Go to
Yes,
module 2.
yes, module
And
2. Yeah.
go to live sessions.
Module 2, where is the lab session?
Scroll down right above
What?
the summary. There's a live sessions link.
No, I can't see a lab session here. Module 1,
It's
review
it's
references.
it
It
called
is live session,
live
live
session.
session.
Ah,
With
live session. Okay.
Doctor,
Okay.
about a question about task 2 of the assignment. Question 2, task 2, question 2. Define 5-fold cross-validation to train and evaluate the 2 models based on average score. So, 5-fold cross-validation, do we have to write codes to do the 5-fold cross-validation?
Yes, it should be taught in the it also should be taught in the lab notebook. So you don't need to manually write it. There is a function or code snippet to do that.
K-fold.
Yeah.
Okay, yeah, I can see that. And the other thing is apply parameter fine-tuning steps to 2 models separately to optimize. So, excuse me, to fine-tuning. Oh yeah, Beautiful. Thank you. It's also there. Thank you.
No worries.
Quick query here. So in the assessment one, like we need to submit the two files. One is the code file and the other is the report file. So in the code file, just we need to just present the screenshots of the code which we have executed.
No, for the code file, you need to submit the notebook file, the
This notebook file.
IPyNB file. Just like the lab exercise, you need to submit this notebook file.
Okay.
Yeah, that's for the code, and you need also submit a written report that is in PDF.
Okay. Yeah. Thank you.
Yeah.
Do we have to do it using Colab, or is that okay if I use like PyCharm and send you
It doesn't matter.
PyCharm?
You can choose your preferred IDE as long as your submission is the notebook file and the PDF report.
Yeah.
In the collab file, like we need only to write the questions, like we create a notebook and we need to write each and every question and we need to do the execution and we need to send that file, right?
Can you repeat the question again?
As you mentioned, like in task 1 and task 2, we have different codes to execute. So in the notebook file, which we create by ourselves, as you know, as you don't provide any notebook file, right? We don't have any notebook file, so we need to create by ourselves. And for each question, we need to write the question and we need to write the code and we need to execute, right?
Although it is called question, like task 1 and task 2, they are highly like correlated. Like task 1 is kind of pre-processing the data set, and task 2 is you're going to do the regression on the cleaned data set. So you need to put everything together. And to finish the task, you need to follow the logic and the workflow, right? So just organize the code in this logical workflow. You can check the like lab 2 regression notebook as a reference. So it shows a clear logic workflow for these tasks.
Doctor, I have seen the lab 2 part 1 underscore regression IP1NB, but that is not Python code, no. That is, there is no code, it's just curly bracket and there is no code here actually. The regression, there is no regression code here. I don't know whether I'm looking at the same thing. That's what I'm looking at. Yes, regression dot IPYNB.
Yes, that's the notebook, right? That's the notebook with code.
Well, but it just what I see is that I can see, right, this is not Python code. There's a curly bracket, then cells, bracket, then curly brackets, and so on. That's
Have you downloaded, or you mean you click it like this?
yeah. This is what we that, but that is not. I don't see any regression here.
Sorry, I don't get your question.
Well, what is this code? This
is the code file I already talked about. If you
yes,
want
but
to, if
it
you
is not doing any
want to,
regression.
this is the
Yeah,
regression
we
notebook.
discussed
You
this
need to download.
at the beginning of this session. We discussed like you have to download this one. Once you download, like
I know all that. I have.
doc,
I know all that. But this
Dr.
is this code is not doing any regression. I know we have to download all this. I know all that.
Okay.
Yes, but this is not any. It doesn't do any regression here.
What do you mean by not doing regression?
You see the code. My God, this is. I have already done this assignment. Regression. I use. There are Python library functions which can be used for regression. I have used that function. That's a very small code.
So I don't get your question.
Actually, what he's saying is the lab 2 part 1 regression IPYNB file, where it should have the code for regression is missing there. It is only having the quotes, like the curly quotes is what.
It has regression there. And here is the regression. It is training like
Yeah.
it is training the SVM model, and I can find another place for training the linear regression because it is week 2 content. I haven't talked about that yet. So I asked you to preview it. I still don't get the point why you're saying it is not doing regression.
I can see I download the IPy notebook and then I check the code. It has the fully contents. Maybe you haven't really downloaded the full file or just share your screen.
Yeah, you can share your screen if I don't get the
Can I share my screen and show you? It's very simple. I can share my screen. I share my screen first. Okay.
I think you need to open the file in a collab. You may have not done
Now
that.
I'll show you my code, what I have done here. Yeah.
Yeah, you can. I will stop sharing and you can share your screen.
Okay, but okay, I'll share my screen. That's the best.
And at the same time, I saw a question like, will
Can you
you be
can you see my
checking?
screen?
Yes.
Yeah, but that's all you have to do. You pass the data set and
This is
What
is
this is not the lab's content, right?
this is
no,
your
it's not
own
the lab. I
content.
have already done it because you don't I can use my own way. No, I don't have to follow the same code. But this is very simple. You get the data sets and split it into 5-fold and then pass it on to the linear regression. And this code is very small, very compact. And you get the values, you get the results. These are all Python functions.
So I'm quite confused. So
What did you complain for?
Well,
yeah.
the regression, your complete is that do the regression and compare the results. With the regression, you get a score.
What's your problem?
I don't have any. I'm asking you because I don't have to use that code, but I have already done it. It's a very simple, simple code, very compact code. You have to do a linear regression. No, there's a function in Python, so you can do the linear regression. You pass the data set.
If you think that's the right way you can do it, then you can submit that.
Yeah, that's what I want to know. I don't have to do it because I can do it my own way. No.
Let's, as the instruction said,
You get the result, you get the score.
I'm not going to mark it right now, and if you think that is the right way to do that, just go for it.
Okay.
But as the instruction said, you need to submit the code that is in IPy notebook format, and you need to also submit the PDF report, and that's the requirement.
That's right, yes. Okay, that's what because I haven't used that. I know that I've seen that, but I have not used that. But don't have to use it. You get the same results, you get you have to do the regression for SVM and also the
Okay, I think I need to answer another question. I saw the Ben's question. So will you be checking the IPy notebook file by executing on Google Drive? So just another note that after you run your IPy notebook file, the result will be shown there. So keep the result there and don't clear those results. And we don't need so that we don't need to rerun your notebook to see the updated result, and just leave your executed result there.
Yeah. Well, what I mean is, what I'm showing is not the Colab. Colab is separate there, but I don't want to load it, and I just show my own code somewhere else. I did the notepad.
Okay.
Yeah.
Any other questions?
Okay. Yeah.
So if no more questions regarding the lab contents, I may stop recording and we can do some like personal consultation. And if you don't have any more questions, feel free to leave and I will see you next week.
Yeah, I have another doubt. The one, like the task one and task two, we need to submit a Word file too, right? Like whatever we've performed in the code for the questions, for task and task two questions, just we need to explain those things in the report, like Word document, which need to have 1,000 word document, right?
Let me see. Okay. So just for example, for task one, like step one, it asks you to describe the data set, describe the variable type, data shape, and consider. You may also consider applying correlation analysis, although it is optional. So to answer this kind of question, you need to run code, right? So this code should be in your lab notebook, in your notebook, Python notebook file, and the result you need to translate it into like plain language into and write it in your report, right? You cannot just let the code tell the story.
Okay, just we need to explain the results for the each and every task,
Yes,
task.
yes.
Okay. Yep. Thank you.
And the actual process should be the procedure or the steps you get to that result should be shown in your code notebook. Okay, I will stop recording. And we can do the student consultation.